Okay, finally, I will talk about problem number 25. How many integers between 100 and 999 inclusive have the property that some permutations of its digits is a multiple of 11 between 100 and 999? For example, both 121 and 211 have this property. Okay, so first make sure that we understand this question. 121 is already a multiple of 11. It is 11 times 11. 121. So yes, it has this property. 211 is not a multiple of 11, but if you change the order of its digits, if you put one over here, they becomes 121, and then it is a multiple of 11. So it has this property. So this is saying if you change the order of its digits somehow and it becomes a multiple of 11, then it satisfies this property. Okay, so yes. Okay, the first method is like the stupid method, but it's actually, I mean, the easiest to think of, and it's quite safe. So you realize that there are, how many multiples of 11 are there between 100, 100 and 999? You realize that there are, so you do 999 minus 100. Sorry, I shouldn't do that. I should start with like the first multiple of 11 after 100. So we know that 99 is a multiple of 11. So after that, it should be 110. So this is the first number that is a multiple of 999. And we know that 990 is a multiple of 11. If you add 11 to that, it's over 999. So this is the last number within this range that is a multiple of 11. So between these, you go this minus this divided by 11 plus 1. This gives you 89. So you know that there are 89, sorry, this gives you 81. So you know that there are 81 numbers that are multiples of 11 within this range. So, I mean, it's not that much. It's just 91 of them. If you write them in a square, like as in like a square, it's not that much. So you can just write them all out and see how many permutations they have. And that is actually quite a safe choice if you like have enough time and really want to crack this problem. So yeah, I'll start here. So it starts with 110. Then it's 121, 133, 140, 32, 43, 54, 65. I mean, it really has the pattern here. So you don't really need to spend much time in calculation. And then you go to 209, 220, 31. So now like this number will be this number plus 2. So you have 4, 2, 5, 3, 6, 4, 7, 5, 8, 6, 9, 7. Okay, now you have 308. Then you have 319, 330. I mean, you don't really need to list out all of them, but you have an idea of what number is there, right? So like somewhere here, you will have a number 407. You do realize this pattern, so you will have numbers 506, 605, 704, 803, 902. And you just can write out the list of the multiples of 11 in like 900 something. So this will be 902 plus 11, 913, 924, 935, 946, 957, 968, 979, and finally 990. So these are all the numbers here. And you also realize something, that you have 110, 220, 330. I mean, of course, these are like the 10 times 11, 20 times 11, 30 times 11. So you can write out this diagonal, which is also quite quick. Okay, so now you have like a general idea of what these numbers are. You can definitely fill them out. It will not take that much time, but you can stop right now and think like, what am I looking for here? So for a random number here, like what permutation does it have? It has, let's call it ABC for the three numbers. Then it has a, yeah, and let me just write 198 and it will be clear. So it has 198, 189, 981, 918, 819, and 891. I mean, they all look quite normal and quite natural, right? There isn't something like that bad about them. I mean, so this like they can all satisfy as being a number with the property. But if you choose a number here, then you can only have 990 and 909 because two of them are the same. So like you change 9 and 9 doesn't make a difference. And also 0 cannot be the first of the like the first digits because it has to be over 100 here. So 99 will not count. So this is what I mean by like 198. It doesn't have like any strange ones because all of the permutations satisfy, but for 990, not all of them satisfy. So now you realize that if you have 0, then probably you won't be satisfying all. So you can see that here for these numbers here, like they all of them can't have the 0 on it first because you can have 29 as a permutation, right? And then you also realize that 209 and 902, they are the same numbers. So when you do the permutations of 209, it's the same as doing permutations of 902. So yes, now you have realized like by observing them, like it might be difficult to come up with them yourself, but when you write them out and observe them, you'll easily see that first, like you have to consider that if it has 0 as one of these digits, because 0 can't be the first digit. And then you realize that some may have the same set of numbers, So even if 209 has 4 permutations, there are 209, 902, 290, and 920. Let me write them out. 209, 902, 290, 920. However, you can't just times 4 for everything here because 902 has the same set of numbers. So it also has these 4 permutations. So you cannot count them twice. So yeah, now you just try to observe the numbers here. You realize that like these numbers, they have, these numbers. Okay, I would assume that this one here as well. Let's see. You have 330, 341, 352. Yes, 363. Maybe also here 484. This one, and and then we would have 5. 5 doesn't have that one. 5 would be 550, but we already counted with the zeros. Then we have 616 here, 737, 858, and 979. Okay, so these are the numbers that are like ABA, so that their permutations can only be, let's just write this one for 484. It can only be 484, 448, and 844 because 2 of the numbers are the same, and it doesn't have 0, so it won't be have like a situation in 99 like here. So I mean, okay, let's use blue for these numbers. So basically these are all the special numbers that we have, like all the different cases of how many permutations it has. Okay, let me write it in blue to make things clearer. And in this one, let's just write it in another color to show that it's like the normal one, the one that has all permutations that you can ask for. Okay. So yes, you can just start adding them up now. And oh, one more thing to notice here. Let's find an example. Yeah, like this one. 132 and 231 are the same. So for all the orange ones, like there are also 2 other permutations here. So like for 189, we can also see that 891 is here. So yes, for each of them, like similar to the case in red, you can only count them once because if you change the, yeah, this is actually a property of the multiples of 11. If you change the first digit and the third digit for all 3-digit multiples of 11, if you change the first and the third digit, it will still be a multiple of 11. You can know this by just, I mean, if you want to prove it, you can say a number A, B, C, it will equal to 100A plus 10B plus 10C. If this is a multiple of 11, then you can prove that 100C plus 10B plus A is also a multiple of 11. You can do this by subtracting this with this. You will see that the the subtraction would be a multiple of 11. So that this is, which is CBA, would also be a multiple of 11. Okay, so yes, and now you just add them up together. So the normal ones, okay, so first the red ones, there are 1, 2, 3, 4, 5, 6, 7, 8 of them. Oh, let me use red. Yeah, so there are 8 of them. Each has 4 permutations, but 2 of them are the same. Plus there are 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 of these, each has 2, and there's no duplicates. Plus the green ones, 1, 2, 3, 4, 5, 6, 7, 8. There are 8 of these times 3 permutations and no duplicates. Okay, plus there are, what else? We have 89 in total, minus 8, minus 9, minus 8. This is how many numbers left that are black, I mean, orange that we have. They have 6 permutations, but we can only take half of them because, yeah, 2 of them are the same. And then you will get the number 168. So the, sorry, what is this? 226. Sorry, 168 is actually the answer to this. So the answer is 226. And the answer to this question is A. Okay, so the first method will be to list out and define pattern. Because out of our head, it is not that easy to think of how to like put them into different cases and calculate them. And it's not that easy to see like what are the things that I need to be aware of here. So yes, you just write them out and you will see what happens. And also it's just not that difficult to write out all of them. You can fill in the white blanks here and here, and I mean it might help, so it's not that difficult to do. Okay, the second method, I will write it here. Okay, second method is that you will realize that for each, like, if we don't consider the situation where there's 0, so each 3-digit number will have 6 permutations, and they will be all between 190 and 199 if we don't consider 0. And we know that if we change the first and the third digit, it will still be the same. So that for a normal number, it will have 3 permutations, like each, because like another number will have the other 3 permutations, and like together you will have the 6 permutations of your same set of 3 numbers. So like on average, a number would have 3 permutations. So you have 91 numbers in total, and each of them has 3 permutations. Like, yeah, to explain more, if the number does not have another number that is the same when you switch the first and the third digits, meaning that if the first and the third digits are the same, then you have 3 permutations, and these will be your 3 permutations. If you're a number that the first and the third digits are not the same, then like you will find a partner or like someone else, some number else who has the same set of 3 numbers, and together you will have 6 permutations. So each you have 3 permutations. So yes, on average, a number would have 3 permutations. This gives us 243. And you know that there will be cases where there are 0, because you already know that 110 and like 990, these are multiples of 11, so they will not have as many permutations as like an average of 3. So the number you want needs to be less than 243, and the only number among A, B, C, D, and E that satisfies this is A. So the answer to this question can only be A. So this is like a tricky way to do it. I mean, if you don't have enough time and you can quickly think of this reasoning, it's really helpful. But yeah, it's not that like helpful if you're doing like really want to rigorously solve this question. And adding to that, if you just don't use this, like don't use this here. Now you only know that for an average number, if it doesn't have zero, like the only condition here is if it doesn't have zero, then it will on average have 3 permutations. So now you only need to pick out those who has zero and subtract them. So yeah, still it'd be a lot more easier to realize that these numbers 330 up until 990, and then 209, 308, 407 until 902. Like if you write this thing out, you will quickly see that these and these are the numbers that have zero. But if you don't, and if you can think of this, then you can just subtract the extra cases for them, and you will also get to the same answer as 226. So yes, the answer to this is A. And that's all for the final five questions of our lesson 1.